Yeah, good morning once again. Back here with a lesson. In the last class, we have started the second module unit that is getting started with an Android. So first, as I have discussed, what are the things we are going to study in a module two, and then we have started with what actually the Android is and how Android came into existence and how the different versions of an Android has been initiated until the Q. We have seen how the years wise with the different features, the Android improved versions has been introduced, and what are the features that are there in Android. And later on, we have gone with an Android architecture. There we have seen how the applications will be there in a top layer, and the basement layer will be with the kernel, means which will in turn with an hardware. So the Linux kernel will be there, and then in between, below the applications, the activities, means activity management, all that management programs will be there. And in turn, below that, many library packages or a library packages will be there. And another one important thing is the virtual machine, which will be there, how it will be in a middleware between the means above active programs and the kernel that we had discussed in a last class. Now I will share the PPT. We'll continue with an architecture of an Android operating system. Yeah, back here in the last class, we are discussing on this particular thing. The first thing which we have gone with the stack architecture of the Android, and you have seen how the applications are there in a above layer and application framework with programs, means like SDK programs, Java programs, especially, which has been written for an active manager, window manager, and all. And later on, the another thing is core libraries will be there, and library packages, additional things which you can have in a Android operating system. And another one is the weak virtual machine will be there, and Linux kernel. So in the last class only, we have started with discussing the Linux kernel. So that is built on a top of version 2.6 and 3 version of an Linux kernel will be there, and it's portable. That I have explained you how it will be portable from one device to another device, how the application framework programs, that is a bytecode, will be converted to the bit code. And Linux kernel knows only the bit code which will be taken, and it will be interact with the different devices within a device drivers. So on a security, that also we have discussed how a multi-process can be done, and how the environment will be there. And another one important thing is power management. See, this power management, as I told you, that one of the very important feature which will be there in a Linux kernel. So here, how the power management will be done in Android, how this particular thing, device driver, will be taken into the consideration, and how battery utilizations will be done. Why? Because actually the mobile is a portable smart device with a lot of applications will be there, as a core applications, and other applications will also be there. User will be continuously keep on using that particular smartphone. And what about the usage of the power? So how a power management will be done? When I'm a search with when I searched the extended knowledge or extended information on this power management in a Google, I saw that one of the foreign universities, they had one lecture itself on power management about an Android operating system. I felt it's one of the interesting thing. Means actually it's an electronics department, and electronics in electronics subject they have teaching that particular thing. But we should also know about how power management is very much important. Why? Because in later stages we are designing an apps, and our app, how it will do the power management when the user is using that particular app, and how much power we can utilize based on that. So now I'll stop this sharing and just have a look on that, not in depth of the topic there with electronic concepts and all, just how a power management distribution means concept will be there. Just I will share another one particular slide here. Yeah. Yeah, Linux power management. So here the Linux power management of two types will be there. One is an APM and another one is a ACPI. APM is advanced power management, and ACPI advanced configuration and power interfaces. How we are interfacing a battery and all, how a configuration will be done in an advanced manner, and how advanced power management will be done. So in this, just a minute. Yeah. Coming to the APM, you can see here the important things is, yeah. Control resides in BIOS. So you know the BIOS, the one of the very important thing, means BIOS is the one which will start first, means which will boots even the operating system. Before that, BIOS is the one which will configures all the components, whatever is there, and it will invokes all the device drivers, whatever is there in your particular device, like a mobile, it can take into the consideration. Uses activity timeouts to determine when to power down a device. So it uses, means APM, it will uses how the timeouts it will take, when to make the power inactive and when. It means in your mobiles and all, you can set for 30 seconds or 15 seconds, default 15 seconds will be there. Even for 1 minute you can set. It's there, the option is also there when the power down should be there. The BIOS rarely used in embedded devices, actually, to say, and makes power management decisions without informing OS or individual applications. No knowledge of add-in cards or new devices will be there according to the BIOS. So this is one thing. And Linux power management in APM, how the thing will be there. You can see this particular diagram here. Yeah, APM aware applications will be there, means whatever a program you have written for that particular power management and all, and APM driver will be there, the kernel which will handle this particular thing, and APM BIOS will be there. So above the BIOS means the BIOS and driver, how it will work within a system call. See, now uses a layered approach to manage devices. APM aware applications include a device drivers talk to an OS specific APM driver. The driver communicates to the APM aware BIOS, which controls the hardware. In turn, it's going to control that particular hardware. So that is a one particular thing which when communication occurs, whatever a communication is there, just a minute, the communication occurs in both directions, power management events, and sent from the BIOS to the APM driver, and the APM driver sends information and request to the BIOS via function calls. That I have told you, system calls, how it is going to work. So what actually when to shut down, means when it has to go to the sleep mode, when it has power management, when the power should be shut down, and when the inactiveness should be there, when the activeness should be there, based on triggering from a user. So in this way, the APM driver is an intermediary between the BIOS and the operating system. So APM driver, whatever is there in a kernel, it will become an intermediary between the BIOS, whatever is there, means the hardware, whatever is there, and whatever the programs, means that how the programs what you have written using SDK and all for power management. Between them, as I told you, so virtual machine will be there. So in that, this is one of the work the APM will do in that particular thing. Coming to the next thing, power management happens in two ways. That is through function calls from the APM driver to the BIOS requesting power state changes and automatically based on device activity. So two ways it will be there. How, whatever, whenever a user triggers or whenever a user wants something, means he goes with some events and all. So APM means function calls will occur between the APM driver and a BIOS, and automatically the other is there automatic things, means if I'm not using my mobile continuously for 30 seconds, automatically the power should mode should go to the inactive, means sleepy mode it should go, where power utilization will not be there. Then automatically when I will see now this is my mobile is in a inactive mode. So but whenever a calls comes, this is another one very important, it's not shut down here, it's not power off here. So that you have to keep in your mind, it's in a sleepy mode, just a sleepy mode. Whenever a call will come, this is very important, I'm not touching my mobile. Whenever a call will come, automatically the mobile starts ringing. So on that particular moment, I can see who is called and all power means activation of a power will be there here. So this will be done automatically when call has been received in so and so frequency from an antenna. So that things will be written in a advanced power management. Coming to the next thing, you can see the complete architecture of this particular APM. That is, applications will be there. That is APM aware applications. Whatever you are going to use your power button just to unlock this, whatever things you are using. That particular thing whenever a call comes and all, APM aware applications, and then device drivers will be there, and APM driver will be there as in a kernel, and APM BIOS. So that's the one interface which will embed it in a operating, means the device of that particular thing. So coming to the ACPI, this how the things will be controlled here, means control divided between BIOS and OS, decisions managed through the operating system. So whatever the controls you have there of an active power management or power interfaces, the controls will be there. So that will be divided between operating system and a BIOS. So decisions managed always through the operating system, that is your kernel will manage everything. Enable sophisticated power policies for general purpose computers with standard usage patterns and hardware. Here it comes with a system that how the whatever battery you are using, how much power will be there once it is 100% charged. So then from that particular stage, how power utilization should be done. For example, when it comes below 20% in my particular Note 8 Pro, then it will give me the indication that you are out of the power, that power is below 20%. And my battery charge, what is it showing? It will become the red. So automatically a notification will be given to me from my particular set or on a mobile. So how these things will be done? Sorry. No knowledge of device specific scenarios. So example, need to provide a predictable response times or to respond to a critical events over an extended period. So this device specific scenarios knowledge will not be there here. So coming to the next, ASPI specification defines the following four global GX states and six sleep SX states for an ACPI compliant computer systems. That is Go SO working. Away mode is a subset of SO where monitor is off but background tasks are running. Like what I told you, that the background tasks, whatever will be there, how much power is there and all, when call comes automatically it will receive. Means here only the monitor, your screen, whatever is there, it will be goes in a sleep mode, or and it will be always in a awake mode, your system. G1. What is this G1? Sleeping subdivides into the four status S1 through S4. S1, all processor caches are flushed and the CPU stop executing instructions. Power to the CPU and RAM is maintained. Devices that do not indicate they must remain on a or on may be powered down. So this is a S1, all process caches are flush, means once everything is flush, means whatever is there in a memory, everything has been removed, and your CPU stop executing the instructions, whatever is there, when power off has been done. So power to the CPUs and RAM is maintained for rebooting and all what's the purpose is needed. S2, CPU powered off, dirty cache is flushed to the RAM. S3, commonly referred to as standby, sleep, or suspend to the RAM. RAM remains powered. In this particular thing, only RAM remains in a powered, and your system will be in a standby mode or a sleepy mode. So S4, same thing in your when you are using Android, same things will be there in your system also. So suspend to the disk. All content of main memory is saved to a non-volatile memory, such as hardware, and is powered down. Hard disk, whatever is there like that, means permanent memory, and remaining thing will be shut down everything. Now, G2 means soft off and mechanical off. The computer's power has been totally removed via a of legacy state. In this state, the hardware and power are not managed via ACPI, effectively disabling ACPI. In legacy state, it will be done like that. So Linux power management in ACPIs overall, you can see how it's going to work. You can see the power file power off is there in a G3 and SO. So it's a working mode. And how it is going to work. So this another one. My power mode is there. SysFS to know about an is there expand. So in this and system app and system is running now. This is a one particular stage. It will always goes. Built as a wrapper to the Linux power management in kernel. What happens? Added on state in the power state. Added early suspend framework. Added partial wake lock mechanisms. So these are all the system calls which will be there in a kernel. So what this particular wake locks means, apps and services must request CPU's resource with wake calls. Whatever your apps which have been developed and all, it will be there. If it needs a power and all, it must ask the CPU for a service. How it will ask? It will ask with wake locks. Through the Android application framework, whatever the framework you have seen in architecture, and native Linux libraries in order to keep power on. Otherwise, Android will shut down the CPU. So that you have to think how your app should be. That's why I've taken this other part of an syllabus. It's not there in your syllabus, but have taken. You must know how these things will work. Apps and services must request CPU resource with wake locks. Underline this, wake locks. Through the Android application framework, that is in your coding, it's like whatever coding you have done. So in that particular coding, that means when you are developing an app, power management itself will be another one particular part will be there. So that is the difference between a professionalized app developer and a non-professionalized app developer. layer also have seen in architecture. So libraries in order to keep power on. And coming to the next point, you can see here Android power management uses wake locks and timeout mechanisms to switch state of system power so that system power consumption decreases. Underline this particular word. So it will waits for a wake locks, means Android power management. Otherwise, what happens? It will waits in a timeout mode. A particular time the app not used. For example, I will open one particular app. Assume here I am opening any of the apps you can open. I will open Android Adobe thing which I have opened one particular app here, and I will keep on seeing. After opening the app, I will keep my mobile aside. Now the app is opened, means app is running. Correct, no? So now app is running means operating system is below that, means my application is running on that particular Android platform. Then automatically some particular time after occurs, my mobile will go down, means in a S0 mode it will goes, and it will come back to this particular stage. So now it's gone back. Now again, if I press any button, something like that, if I unlock that, then only the app will be in that particular stage only. But now this app, whatever is there, when the my mobile goes into an inactive mode, then whatever my app, what my app state should be there. So that is also an important thing which you should know as an app developers. Coming to the next thing is yeah, apps and services must request CPU resource with the app locks. It's over, right? Next, wake locks. By default, Android tries to put the system into a sleep or a better suspend mode as soon as possible. Why? Because for a power utilization. Applications running in a Dalvik virtual machine, underline that. The applications always run, it will runs within a Dalvik virtual machine, can prevent the system from entering a sleep or in a suspend state. That is, applications can ensure that the screen stays on or the CPU stays awake to react quickly to the interrupts. So you have to make that. You have to make, means your application is running on a Dalvik virtual machine, as I told you already. So here can prevent the system from entering to the sleep mode. For example, user is entering a data, user is reading some information in a data, assume it will take some particular time. Then automatically if it goes to a sleep mode and all, it makes the user disturbance. So how to make it should be opened so that your application should interact with that. The means Android provides for this task is wake locks will be provided. If there are no active wake locks, CPU will be turned off. If there are partial wake locks, screen and keyboard will be turned off. So it depends what actual means which actual things you want. Types of wake locks. Partial wake lock is there, that is an ensures that the CPU is running, the screen might not be on. So background CPU is running. When I have told that I have opened one particular app and I will keep aside, then automatically my screen, whatever is there, it will go with an off state and my CPU will be keep on running. That's why my app is also in a running state. Whatever work the user has did, for example, he has entered 5 fields and remaining 5 fields is there, he will keep the mobile phone aside, some work he has gone. So next, there is no need to him to enter from beginning again or to open my app from a beginning. So screen dim wake lock, that is wake lock that ensures that the screen is on but the keyboard backlight will be allowed to go off and the screen backlight will be allowed to go dim. In initial stage, when you keep the mobile aside, I mean you are not working, means automatically it will goes down in there's an initial stage in a mobile, it will goes down. Later on, if you are not at all using, then an entire screen will go down in a partial wake lock. Then screen bright awake lock, that is awake the lock that ensures that the screen is on at a full brightness, the keyboard backlight will be allowed to go off. this is one particular condition in apps which you may need. Full wake lock, that is full device on including backlight and a screen. Android power management design. Android implements an application framework on the top of the kernel called Android Power Management Applications Framework, which you have seen in our architecture. The power management framework is also there. The Android power management framework is like a driver. It is written in Java, which connects to the Android power driver through JNI. Next, currently Android only supports screen, keyboard, buttons, backlight, and brightness of the screen. Only these things is there in that particular design. Through the framework, user space applications can use power manager class to control the power state of the device. That means you can use a class called as a power manager. Say applications, application A, application framework. In that, power manager is the class which you are going to use. Create a wake lock there. Linux power management is there. According to your wake lock, it will interact with a Linux kernel, and the Linux kernel it will in turn interacts with your power management, that is your CPU, LCD, keyboard, whatever is there, which utilizes the powers. So in depth, if you want to say this particular thing, application A, B, C is there. So new wake locks, how you are going to create, and android.os.power manager, android.os.power, and manager services which you can take, core library files, so which you want you can take when you need. Otherwise, it's left to the user designer, power.c, which you can use there. Android power management, Linux drivers will be there. So the byte code will be taken to the bit code, how it is going to take, you can see here. A finite state machine of an Android power management touch screen or a keyboard user activity event or full awake locks acquired. You can see how it's going to work here. Awake up, source, timeout for a power key pressed, and it's coming back, notification, touch or keyboard user activity event. So when user touches, something will happen, notification, all partial wake locks released, then coming to the partial wake lock required. So Android power management design, which you can do, but we doesn't need that actually. Until this, we must know. So design and all, we are not there to design that particular things and all. So I'll stop here. Then you understood how the power management things can be done in particular. That again, I'll go back to our PPT. Just 1 minute. Yeah, I'll share this. Right. Now again, you can see how now you got an idea that your application thing, whatever is there now here, the power manager will be there, and from power manager, how you are going to, if you want, you can utilize the library. Otherwise, Davik virtual machine, how it will be there, and Linux in this, how you are going to take the power management. So after this, we'll go to the next thing. Yeah, that is another layer. Sorry, native libraries, whatever is there, that will be in a C, C++ code, that you have to keep in your mind. So that will be there in a C, C++ code. Then the surface manager, whatever will be there, it will be in a graphics and multimedia, media frameworks will be there, and database, if you want to work with, means I want to store something in my app and I want to retrieve that from my particular app in a mobile itself. I want, means in mobile itself, in a user mobile itself, I want to store a data. When user downloads my particular app, I want to utilize some particular space from him. So that for that and all DBMS concepts you are using, there's an SQLite which you are going to use. SQLite is in a database, like what you will tell MySQL, Oracle, and all, like SQLite will be there. So where some amount of data, not like a large amount of data, some amount of data of credentials which you can major credentials which you can keep and store in that particular app itself. Font. So management, the font management will be there. That's on a free type which is been used. And WebKit will be there and other C libraries will be there. So what all these things you are going to use as an native libraries. Coming to the next thing, application libraries. What is this application libraries? Here, Active Manager is there. You can see the frameworks, core components of an Android. This is very much important. Means with this particular class or a packages only, you can do the codings and you can connect and you can use the different features of a phone, that smartphone in your app and all. So Activity Manager will be there. That's one of the skeleton for your particular app, and Packet Manager will be there. Telephony manager will be there. Telephony means connecting to other devices or sending SMSs, receiving SMSs, or calling other persons through your app, something like that you are doing. That's a telephony manager. Packet manager, the information sending from your particular app to another particular app and receiving that particular thing. Location manager, any GPS concepts if you want to use in your particular app, that is you want to send a location, that is a longitude, latitude, and location information from one set to another set, and tracking the longitude and latitudes of that particular thing. All this related means GPS related things, location based related things will be there in this particular package. Our contents provider, as I told you that how a contents will be provided, information will be provided either from a SQLite or any other things where you are stored from cloud and all. So how you are providing the contents, your what way you are providing the contents. You want to provide in the way which you want, means one particular way and all. So notification manager, this is another one very important. When notification has to give at what every frequent time the notification has to give. When new item comes to your craft or an invoice, the notification should be given. It depends on your app that when you want to give a notification. For example, continuously user has not used your app for 24 hours, then when you want to give a notification to him, it depends on your app needs. How you are going to give a notification. For example, for a farmer and all, if you want to give a notification that in our particular app design, when banker will tell yes, loan is sanctioned, so and so loan, everything approvals he will give, assume. Until the farmer will open the particular app, he doesn't come to know that without notification, it doesn't come to know that so much approval has been done. So if you give a notification here for him, for example, so-and-so bank approved so-and-so amount. If he clicks on that particular thing, then our app should be opened for him. Just I'm telling one particular sequence or scenario for you. For example, the farmer has uploaded one particular plant with a pest, and he is awaiting for experts for how this pest control can be done. And in a forum, the pest means experts has put some suggestions to him. How that suggestions? Yes, suggestion is there from so-and-so expert. A notification should be given to the farmer. Once he sees the notification, he clicks on that, our app will be opened, and now you can see what are the comments the expert has given, like that. So this notification manager is another one very important framework which we are going to use. Coming to the next, in applications wise, written in Java code. So Android Play Store, whatever is there, so that's another one thing. And in that you can see the entertainment will be there, productivity will be there, personalization will be there, education, geo communication. These are all the applications which will be written on a Java code, so that anybody can see that particular, it's a front end, how user will use that particular components. Then Dalvik virtual machine. What actually this Dalvik virtual machine? Novel Java virtual machine implementation not using the Oracle JVM. open license Oracle JVM is not open. Optimized for a memory constrained devices faster than a Oracle JVM, we are going to use this Dalvik virtual machine. Because of that, we are not using the Oracle JVM, Java virtual machine, we are not using. Now Java is there with a Oracle, we know that. It's a open license is there, but it's not opened. Means it's not opened fully. So because of that particular reason, the whatever the open standards is there, they are using a Dalvik virtual machine, and it's faster than the Oracle Java virtual machine. Same work it will do. That means whatever a bytecode is there, it will take that and it will convert to the bit code, and it will transfer that to the Linux kernel. So same work it will be done. Coming to the Dalvik Java virtual machine. So you can see that's a JVM which you can Java source code will be there. Java standard additions, the source code is coming. Compiler Java bytecode will be generated from that, and you can see the Dalvik virtual machine here and Java virtual machine. Stack based bytecode will be taken here. Dex compiler will be there. So Dalvik bytecode will be taken. Registered based bytecode will be taken as an input, and then it will convert to the bit code. So always registered based bytecode it will take. That's the difference between JVM and a Dalvik bytecode, whatever it's going to take. Then coming to who supports Android, so that also we should know. Android will be supported by HTC, LG, Motorola, and Samsung are the major players in the Android smartphone market. That we know already. So almost all mobiles now, especially another things also is there. There's a Redmi, which has been another one company which is here with Android. Archos, Dell, Samsung, and Toshiba hold the largest pieces of the Android tablet market. The hardware side of the Android is supported by the Open Handset Alliance, that is OHA, that we have seen in a beginning. That how Google and all other companies like HTC, Motorola, LG, Samsung, everyone has been, which is of the many handset manufacturers which are there. So with that, OnePlus, whatever is there, so that's the companies which are coming, Oppo, OneSets, these are all under one frame it will come, Redmi, means Xiaomi companies. So these company which are all the alliance together as an open handsets, and they are implementing that particular Android. Why target Android? Why they have gone for a targeting Android? Why Android is needed? Among the many reasons to target the Android platform, first and the foremost is cost. It's a free open source, the best thing, and it's alliance to one platform. The cost especially means there is no need ownership to pay for that. On average you can get an Android smartphone for a fraction of the cost of an iPhone. That when you take iPhone into the consideration and Android phone into the consideration, the best example I will give you, the OnePlus phones, whatever you are taking in a market now, you can see the OnePlus phones, the latest one, whatever is there, is almost all competing with your iPhone, the latest versions of 11x, and even 11 Pro and 12 also. So all the features, whatever is there in an iPhone, it will be there even in that particular OnePlus also. But when you see the cost between them, it will comes around some 1,80,000 to 1,20,000 iPhones. And now this OnePlus, whatever in a market price, you can see from 25,000 to 35,000, maximum 35,000 means the 35,000 means you are going to get a very good a smartphone with an Android with lot of features. Next is flexibility. More types of Android devices are available. So if your application fits specific niche market, there is probably a device. Android is another perfectly good reason to target Android. That begin said you should do some research, because if a developer has a targeted iOS or a BlackBerry as a primary platform, you have to assume that Android is potentially on the horizon. So that's why, as a developer, you have to think why even in a syllabus they have kept more on Android and somewhat are less on other things. It really based on a market, so that almost all first have to assume that Android is potentially on the horizon more than any other platforms. So Android as a competition to itself, because Android was designed to be run on many different types of devices created by many different manufacturers. So this is a one very important thing. Many devices means many components, many different components, or many different manufacturers. Their way of architecture will be different. So your Android should be fit on that. So because of the open nature of the Android operating system, means it's a free platform independent, it is common place for manufacturers to create a vendor specific builds of Android. So automatically the manufacturers even they will go with that particular Android based architecture, that thing, and their components will be easily can be communicated with an Android devices. Getting the tools you need, downloading and installing SDK, this I will tell you later. First, we will go with according to your syllabus. It's there like that. You have to download how a JDK and installing Eclipse and all. But actually, to say we will work with Android Studio. Now that will be better one. Working with an Eclipse and all means you have to individually download all the packages, everything you have to do, and then you have to set the path and all. But in Android Studio, directly you can go and directly you can do the coding. So here the differences. But according to the syllabus, we will move. Means whatever theoretical concepts is there, according to the syllabus, we will discuss the differences. But according to the syllabus, we will move. Means whatever theoretical concepts is there, according to the theoretical dimensions and all, I will tell you how you can work with an Android also. For this particular session, I'll stop here. Any questions is there? Now it's open for a discussion. Stop, and it is open for a discussion. Yeah, the session is open for a discussion. Any questions? Any questions? Yeah, answer your attendance. Anaga?
Yes, sir.
Anaga? Yeah. Abhilash?
Yes, sir.
Akhil?
Yes, sir.
Akrut?
Yes, sir.
Anusha?
Yes, sir.
Aravind?
Present, sir.
Alifullah?
Yes, sir.
Benaka?
Present, sir.
Banu Prakash?
Yes, sir.
Bhargav? I repeat, Bhargav?
Yes, sir.
Rahmatullah?
Sir, you put in start box, sir.
Okay. Chaitra?
Present, sir.
Chandana?
Present, sir.
Karan?
Yes, sir.
Darshan?
Present, sir.
Next, Diksha?
Diksha, present, sir.
Dakshayani?
Present, sir.
Kishan?
Kishan is present, sir.
Akshat?
Present, sir.
Hemalata,
Present, sir.
Uma,
Present, sir.
Jayant,
Present, sir.
Divya,
Yes, sir.
Kaushik, ಇಲ್ವಾ ಅವನು ಕೌಶಿಕ್ ಲಕ್ಷ್ಮಿ ಯಾಕೋ ಲೇಟ್ ಆಗಿ ಹೇಳ್ತೀಯ ಯಾವಾಗ್ಲೂ ಲಕ್ಷ್ಮಿ
Present, sir.
ಲಾವಣ್ಯ ಮನೀಶ್
Present, sir.
ಮನೋಜ್
Present, sir.
ಮೋಹಿತ್
Yes, sir.
ರಾವಲ್
Present, sir.
ನವ್ಯ
Present, sir.
ನಿಖಿಲ್
Present, sir.
ಫಣೀಂದ್ರ
Present, sir.
ಪವನ್ ಪೂಜಾ
Present, sir.
ಪೂರ್ಣಿಮಾ
Yes, sir.
ಅಮನ್
Present, sir.
ರಶ್ಮಿ
Yes, sir.
ರೂಪಕ್
Yes, sir.
ಸಾಯಿ ಕುಮಾರ್
Present, sir.
ಸಮೀರ್
Present, sir.
ಸಂತೋಷ್
Present, sir.
ಸುಧಾಪ್
Present, sir.
ಶರಣ್
Present, sir.
ಶಶಾಂಕ್
Present, sir.
ಶೀತಲ್
Present, sir.
ಶಿವಾನಿ
Present, sir.
ಸೌಮ್ಯಶ್ರೀ
Present,
ಪೂರ್ತಿ
Present, sir.
ಶ್ರೀವಿಷ್ಣು
Present, sir. Shri Vishnu.
ಸುಗಂಧಿನಿ
Present, sir.
ಸುಷ್ಮಾ
Present, sir.
ಸುಷ್ಮಿತಾ
Present, sir.
ಸುಷ್ಮಿತಾ ಯು
Present, sir.
ತೀರ್ಥ
Present, sir.
ತೃಪ್ತಿ
Present, sir.
ವರ್ಷಾ
Present, sir.
ವೀಣಾ
Present, sir.
Sir, Pawan, present, sir.
ಪಾರ್ಟಿಸಿಪೆಂಟ್ಸ್ ಅಲ್ಲಿ ಬರೀ 56 ಜನ ಇರ್ತೀರಾ, ಅಟೆಂಡೆನ್ಸ್ ಎಲ್ಲಾರು ಹೇಳ್ತೀರಾ, ಹೆಂಗದು?
Sir, Wi-Fi connection ಹೊರಟೋಯ್ತು sir. Power off ಆಯ್ತು. Wi-Fi connection.
ಎಲ್ಲಾರು ಅದೇ ಹೇಳ್ತಾರೆ, ಕೊನೆನಲ್ಲಿ ಅಟೆಂಡೆನ್ಸ್ ಮಾತ್ರ ಬರ್ತೀರಾ. ನಾನು ಮಧ್ಯದಲ್ಲಿ ಆಗ್ತೀನಿ ಅಟೆಂಡೆನ್ಸ್ ಹೇಳಿದೀನಿ ಇನ್ಮೇಲೆ. ಹಂಗೆಲ್ಲ ಮಾಡಬಾರ್ದು. ನಾವು ಈಗ ಎಷ್ಟು ಜನ ನೋಡು, ಬರೀ 53 ಇದೀರಾ ಇಲ್ಲಿ, ಅಟೆಂಡೆನ್ಸ್ ಎಲ್ಲಾರು ಹೇಳಿದೀರಾ, ಹೇಗೆ? So that's wrong. Stop recording.